Okay, so this question is on the soccer projectile, where we've been given some information about the initial flight parameters. So the takeoff angle, or the ball is kicked at 38 degrees with a resultant velocity of 22 meters a second. So I've just drawn that out, or that time point out here, with that resultant velocity here of 22 meters a second, 38 degrees from the horizontal, and obviously we have horizontal and vertical components of that resultant velocity that are right angles to each other. So part A here, what would the ball's horizontal velocity be just before it impacts the ground? Well, that's the same as the horizontal velocity as it takes off, because as a projectile travels through the air, its horizontal velocity is not changed if we ignore air resistance, which I've obviously outlined in this question here. So we're just trying to solve for this component of the horizontal velocity, which we can use, using Projectile or right angle trigonometry, and in particular the cosine formula, where the adjacent divided by the hypotenuse is equal to the cosine of an angle. So in this case, cosine of 38 degrees must be equal to the horizontal velocity divided by 22, and therefore the horizontal velocity must be equal to 17.34, which I can put down here now. In section B here, what would the height of the ball be at 0.5 seconds after being kicked? And so this is really a question that's going to involve some vertical aspects of projectile motion. So how long a ball is going to spend in the air, how high it is, these are all vertical aspects that we'll end up using laws of constant acceleration to help us out with. But before we get there, we really need to find out the initial vertical velocity of the ball. So we know, for example, the acceleration going up of that ball is going to be negative 9.81 meters a second. We know that the final velocity going up is going to be 0 meters per second, because final velocity upwards, or transitioning from positive to negative, there must be a point of 0 where it's reaching its maximum height. We know the time in this one here, so we know the time is going to be 0.5, although at 0.5 we don't know if it's going to be, if that final velocity is going to be 0. So we're talking about two sort of different things here, but we do need to figure out the initial vertical velocity going up, which we can do from this trigonometry problem over here. So in particular, if we look at the law of sine, being sine of an angle equals opposite over hypotenuse, then in this case the sine of 38 degrees is going to be equal to the vertical velocity, or initial vertical velocity, divided by 22, and therefore initial vertical velocity is going to be equal to 13.54. So 13.54. And so now we can use one of the laws of constant acceleration. In particular, like I said, I'm not keen on using one that's got a final velocity, because we don't know at 0.5 what that final velocity will be. That's for the initial completely going up to rest at the top. And so the law that will help us do that is the second law of constant acceleration, or in particular, we've got S equals VI T add 0.5 AT squared. And if we put in our knowns here, our initial velocity is 13.54, and our time is 0.5. and that's added to 0.5 multiplied by negative 9.81 by time again, which is 0.5. Sorry for the messiness here, we're breaching over these. If we solve for that, put that together though, we get 5.54. Okay, so we're really going right angle trigonometry to get velocity, initial velocity going up, and then we use our laws of constant acceleration to get displacement at that particular time point. Now this is the last one, is a classic question of how far will the ball travel in the air, and so really we're going to need a combination of the horizontal velocity and the time in the air, or in particular horizontal displacement is going to equal horizontal velocity multiplied by time. Okay, and that's the total time in the air. And so because we have these both initial velocities, we already have horizontal velocity there. So we have this ticked off already, and now we just need time. Now we've played around with time here, but we don't actually know what the time is going up and down. We can use this final velocity now of the ball going up must equal 0 to figure out the time going up. So we can use the first law of constant acceleration to do that, which is Vf equals Vi add a t, which is 0 equals 13.54 add negative 9.81 t, and again you rearrange that formula, you're going to end up getting a time up of 1.38. In this case, in the soccer kick, we kick a ball here and we end up landing on what we assume is level ground on a soccer pitch, then the first half of the flight is going to mirror that of the second half of the flight, i.e. the time up is going to be equal to time down, and therefore total time is equal to time up times 2, or 1.38 times 2, or 2.76. So going back to this here, horizontal displacement is going to be equal to horizontal velocity, which is 17.34, multiplied by time, or total time in the air, which is 2.76, which is going to give you 47.87 meters.